Hello, everyone. So we, as a team, have come up with a probability project that is the Shut the Box. So Shut the Box is a popular dice game typically played with two or more players. So for our project, we have considered a two-player game. So the goal of the game is to shut all the numbers, mostly the maximum number of numbered tiles or blocks, by the rolling dice and matching the sum to the numbers on the board. Players take turns rolling the dice and marking off numbers corresponding to the dice roll. The game ends when a player shuts the maximum number of block numbers or cannot make a valid move. And the winner is the player with the lowest total remaining numbered value. It combines luck and strategy in a fun, competitive way. So let's go ahead. So, as you can see in the figure, this is the physical model of a game. Shut the box. So, in this traditional setup, there is a box with numbered wooden tiles from 1 to 9, two six-sided dice, and a cup for rolling the dice. In the game, players roll the dice and select numbers from the dice that sum to the value of their roll. For example, if the sum of the dice comes up to 9, so we can select just 9 numbered block, or we can choose 7 and 2, 6 and 3, 8 and 1. So, and accordingly for the other summed result. So for our project, we have implemented this game digitally using HTML, CSS and JavaScript. So as you can see, we have coded the project using HTML, CSS. Just a minute. Yeah. So here's the view of a project. So the rules are roll two dice to get a sum. Select tiles that sum up to the dice roll value. So let's begin. This is player one's turn. So consider I'm player one. I'm Preet Shah. So I'm rolling the dice. So the result comes up to 10. So I can choose now 9 and 1. Or otherwise, if even you can go with 8 and 2, 7 and 3, and accordingly. So I submit the selected tiles. Again, I have to roll it. And now the sum is 5. So I choose just 5 numbered block. I submit it and again roll the dice. Now the sum comes up to 6. So I select 2 and 4. I submit it and I roll the dice again. Now the sum comes up to 6. Now that I've got the 6 numbered block is spare. So I choose it and submit it again. Now you can see roll result. Player 1 couldn't match the rolled sum of 6. Again, the sum of digits came to be 6. So the player 1 ended his game. Now player 2 begins his game in the similar manner. Let's begin. So this let's roll the dice. It comes up to 2. So 2, submit. Okay. So unfortunately, the sum of digits of the block numbers came out to be 2. So the game ended immediately for the player 2. And if you see, the player 1 wins with the remaining tiles sum of 18. And compared to player 2, which is 43. If you sum up these unblocked, unflipped blocks of numbered blocks, green colors, so that sums up 43. So that's how the game ends. So accordingly, player one wins. So these are the rules and this is how we are supposed to play.
So now we will discuss the probability concept involved in our project. First one is probability of dice roll. Set the box involves rolling the two six-sided dice. So the total possible outcomes are 36, as we all know. The probability of specific sum, that is 7, depends on how many combination of that we can achieve, which is the maximum combination of 7s can be achieved, as we all know. Second one is expected value of dice roll. Knowing the expected value helps in our strategy. Means if we know that 7 has the maximum probability of the sum of the two dice, we can choose the combinations accordingly. Conditional probability. Inside the box, players often need to make decisions based on the current state of the board. For example, if certain numbers have already been covered, the probability of closing out remaining numbers may change depending on the sums depending on the which sums can still be achieved. For instance, if the only numbers 8, 9 and 10 remain, the player must consider the probability of rolling the sums that add up to these values. Fourth one, combination probability. Players can use different combinations of numbers to reach the target sum of their dice roll. For instance, if a player rolls an 8, they could shut 8 or shut 5 and 3 or shut 6 and 2. Calculating the probability of making certain sum through multiple number combinations can guide strategic choices. Independent events. Each roll of the dice is an independent event, meaning that previous roll does not affect the future outcomes. Probability of winning or losing the game. As the game progresses, it becomes increasingly difficult to get rolls that match the exact value needed to close to all numbers. This makes the game stochastic, or we can say random process. Seventh and most important is Markov process or Markov matrix. In the Shut the Box game implementation, we use the Markov process to model the game's progression. Each state represents a unique configuration of open tiles, and transitions between states occur based on the dice rolls. There are total 9 numbers. Each one can be either shut or not shut. So there are total 2 to the power 9, which means 512 states in this process. We can also use a Markov matrix to represent the transition probability between these 512 states. The rows of the matrix correspond to the current state and the columns represent the next possible states after a dice roll. Each matrix entry shows the likelihood of moving from one state to the another. By analyzing the Markov matrix, we can calculate the probability of winning or losing based on the current configuration of the open tiles. We have implemented this game's simulation in MATLAB. For a single player, this can also be played. If a single player plays this game, the game can end in two possible ways. If the player successfully shuts down all the numbers, he or she is win, or if there are no melee moves remain in the game, and if there are certain tiles which are still up, then the player loses. We have performed, as you can see, we have performed simulations for 1,000, 10,000, and even 1 lakh times this game. And after this, we can come to a conclusion that there are just 2% chances of winning this game in one player. As the probability is 1.9%, then 2.17%, and then 2.04%. See our MATLAB code by clicking here. So this is our MATLAB code for set the box simulation. We have made an interesting observation in this. The picture seen on the left side, we have gone from an internet article which shows the probability distribution for different number of six-sided dice and for different number of tiles. You can see there are some peaks between two number of tiles. What does that peak signify? For that, we have to understand this concept. The most combination sum. For a given tile combination from 1 to n, there are certain number of combination for each sum. Let us take example of 4. There are total 10 for 10 sum possible from 1 to 10. Each one can occur in only one way. Similarly, 5 can occur in two ways, 2 or 3, 1 and 4. This shows that the maximum combination occur between these two. So, there is a peak between any two number of tiles. And then also, if we do this for 9 window from 1 to 9, we can see that the 21, 22, 23 and 24 has the maximum number of combinations possible. This is also applied with the maximum probability of getting the sum of two digits, which is 7, which is maximum among all the numbers from 1 to 36. So we can see these types of peaks in the probability distribution. The link to the MATLAB code for generating these combinations, number of combinations, is also given. Here you can see. So thank you.